Welcome everybody. This is a very odd way to give a presentation because basically I'm in my home office talking to my computer, and it's a leap of faith that there's actually people out there. So I just assume there will be, and I'm not just talking to myself. What I'm going to talk about is management of small grain forages, and the way I'm going to do this is basically by comparing it to small grains for grain. Many of you, I'm sure, have experience of growing small grain for grain, but I'm pointing out maybe some of the differences. There's some slight differences, and they're worth noting. Let's see if there we go. So what do we mean by small grain forages? So what we mean is barley, oats, triticale. If you don't know what triticale is, it's a man-made cross between wheat and rye. And there's wheat. There's also cereal rye, which I'm not going to talk much about. That is grown more in the northern states. And there is rye grass. I guess technically that's not a small grain forage, but I'm also not going to talk about ryegrass, but I just want to mention there are a few grasses on here that I'm not going to really spend much time on. So as far as management goes, there's, I got about 7 or so management practices that I'm going to go over briefly and talk about. The picture on the right, by the way, is triticale, and looks like a 2-row triticale. And first thing is there's a variety selection that's a little bit different. The planting dates, seeding rate, fertilizer rate, irrigation amount, pest control, and harvest management. There's slight differences with growing small grains for forages versus for grain. And I'm going to maybe talk a little bit about each of these. As far as variety selection, there are what you might call dual purpose varieties. And sometimes you hear this in corn, dual purpose corn, one for grain and one for silage. Same thing with small grains. And so here you see awned wheat with awns, and on the left, and then you see awnless wheat on the right. There's awnless wheat varieties that are for grain, but the reason they're important for forages, the awnless types, is because the awns, of course, can irritate the mouths of cattle. And so often with varieties specifically forage, they're awnless. In the case of wheat, in the case of barley, they might call it hooded. For example, hooded barley. Hooded barley really has an awn, but it's a deformed awn, and it doesn't have the same structure as a regular awn or beard on barley. So this is one of the big differences between the variety selection for forage and versus grain. And for planting dates, I'm really concentrating on the southwestern part of the U.S. when I talk about planting dates, including the Central Valley of California. And for grain, as an example, in the San Joaquin Valley, the optimum planting time is somewhere between Thanksgiving and the first week or two in December. That's similar in many parts of Arizona. But if you look at an optimum planting window, it's basically January and February for grain. But for forages, you see on the right, you kind of have a wider planting window for a couple reasons. One, for example, you could plant forages, again, in Arizona and Southern California and the San Joaquin Valley. You could plant them in September, for example, winter cereals for forage. And if you were to cut at the boot stage, and so you might be able to cut, say, if you plant in September, you might be able to cut by Christmas at the boot stage. If you were to let that go further on, for grain, for example, something planted at that stage would get freeze damage, and you would have little or no grain. And then later in the season, of course, you could plant later, even up into March if you wanted to. Not that that would necessarily be optimum. Also, if you're cutting at boot, because you basically have almost a half of a season compared to a grain crop. The seeding rate, generally, seeding rate is about 20% higher for winter cereals grown for forages. And so, for example, for wheat and for grain, an optimum seeding rate might be 120 pounds per acre. And then for forage, it might be more like 150. And one of the reasons why seeding rate can be higher in forages is that higher rates produce finer stems, which is desirable. The other thing is, which I'll say this again and again, lodging is not as much of an issue with forages as it is with grain. I'm not saying lodging is not an issue, but in general, lodging can be a lot more detrimental to yield with a grain crop because that's all you have. And lodging, all you have is the grain. You don't have grain and forage. And so oftentimes the lodging will happen, during the grain fill stage and can reduce yield. And also with grain, it's a lot harder to pick it up with a combine than it is with a forage harvester. With fertilizer rates, this is actually a study that I did in Yuma last year, a fertilizer study with wheat. And you can see in this particular photograph, I think what you can see on the left, there's 3 strips actually to the right of a field that was recently planted. And this was actually taken in March, middle of late March. And then we have these 8 strips of a trial, and you can see the different sorts of color patches in these plots. And one thing we know about small winter cereals is that they can be very responsive to nitrogen. I mean, more so than a lot of other crops. One thing about forages is that they're a lot more tolerant of high N rates because lodging is not as damaging. I've done a lot of nitrogen fertilizer studies with wheat, for example, and you get a optimum rate somewhere, and then oftentimes you don't have a plateau at higher rates. You'll have a drop off at higher nitrogen rates that are excessive due to lodging and a shift of the grain to straw ratio at higher rates. In the case of forages, a shift in the grain to straw ratio is not as damaging to yield because you're looking at total yield, not just grain yield. On the other hand, the nitrogen requirement in forages isn't quite as high due to the shorter season for forages, because typically the winter cereals might be cut either at the boot stage or at the soft dough stage. And so for grain, you might have another, at least if it's cut at soft dough, there's another 2 weeks or so from soft dough to physiological maturity. And then also one thing that happens again in wheat is oftentimes a late nitrogen application is made to boost grain protein in wheat, whereas that isn't necessarily necessary in the case of forage. If you look at the irrigation amount, similar to fertilizers, that the forages are more tolerant of high water amounts because lodging is not as damaging. And again, I'm not saying lodging is not an issue in forages, it's just not quite as damaging. But again, due to the shorter season, the water requirement may not be quite as high. You look at weed control, probably the only positive thing about weeds is that weeds contribute to forage yield. But as in most crops, there are a lot of disadvantages to weeds. In a forage in particular that's fed to cattle, that there's some weeds that are not palatable or toxic. There's some weeds actually that are very nutritious, but a lot of them are not palatable or toxic, and they do not dry evenly. In the case of these winter cereals, they are often cut and wilted some before they might be chopped and siled. And so if you have this uneven dryness, it's really not something that's desirable. And the other big thing is that weeds contribute to variability and quality. And so that's a reason to control weeds, even though by controlling weeds, you may reduce forage yield. If you look at insect control, here you see aphids on barley. Insects are usually not a problem in small grains. They are and can be, but usually not. But when they are a problem, they can disproportionately affect grain yield. So that's an issue with forages. In the case of forages, insects, if they are there, probably aren't as much of a problem. If you look at disease control is, in general, chemical control is not economical, and I know there's exceptions to this. It just depends on the disease and what sort of where you are. There's some places in wheat I know that where fungicides are applied routinely, but in general, they often may not be economical. The thing about diseases is they can disproportionately affect yield, and so the other thing is grain yield, I should say. So in the case of forages, perhaps diseases may not be as important. The other thing is there are certain fungal toxins that can occur in wheat, and one example is wheat scab. The toxin is vomitoxin, and if you look at the level of these mycotoxins, by mycotoxin that's fungal toxins, usually the levels that are acceptable are higher in something that is a feed than compared to something that's a food crop. And so in this case, where you have fungal toxins in forages, it's not as important. It is important, but not as important as it might be with grain. And then harvest management, obviously there's a difference because you're harvesting earlier. So you cut at boot or soft dough. And just as an example, I said before, soft dough maybe 2 or even 3 weeks before physiological maturity. And then you have to add another 2 weeks or 3 weeks after that before it's harvest ripe. And so the harvest might be occurring a month or even a month and a half earlier than would happen with a grain crop if you compare cutting at soft dough versus harvest ripe. And then, of course, the ultimate use of the product's different in that it can be direct fed or ensiled. So in summary, small grains can be grown similar whether for grain or forage, except that the varieties are different. Forages can tolerate higher rates of seed, fertilizer, and water, although they may require less fertilizer and water. Pest control is probably not quite as critical for a forage crop compared to a grain crop, and forages are harvested at an earlier stage of growth than grain. So thank you very much for your attention, and I know I finished early, but I'd be happy to take any questions if there are any.